October 15th, 1942. 0230 hours. 300 miles southeast of Newfoundland. The North Atlantic was a realm of churning, black indifference, where waves the size of houses rose and fell under a sliver of an Arctic moon. Below the surface, in the cramped, oil-scented control room of the U-607, Oberleutnant zur See Ernst Mengersen gripped the cold brass rail of the periscope. For the past 6 hours, the constant metallic thrum of steam turbines, the unmistakable signature of a massive Allied convoy, had been vibrating through his hull. This was Convoy SC-107, a vital artery of life ferrying fuel, munitions, and food from North America to the besieged British Isles. And it was his to destroy. In the dim red emergency light, Mengersen barely needed the periscope. His acoustic operators had triangulated the targets perfectly. He whispered the command, Meldung an Kommandant, target, tanker, estimated 10,000 tons, bearing 247, depth 60 feet, set magnetic pistol. This was the happy time, the period of unparalleled U-boat dominance, and Mengersen was its unquestioned king. His coordinated, silent swarm of German submarines, the Wolf Pack, was closing in for the kill, operating with near impunity in a vast, lawless stretch of ocean. Above, the tired Canadian lieutenant commanding the escort could do nothing but pray. Their primitive radar was often useless in the heavy North Atlantic chop, and their only detection tool, the inherited and flawed ASDIC sonar, was effectively blind against the cunning German tactics. Mengersen waited for the perfect moment, then barked, "Feuer!" a tremendous, shuddering whoosh as the torpedo launched, followed by the terrifying, deafening echo of the explosion as the tanker erupted in a fireball visible for 10 miles. As the crew of the U-607 cheered, they were celebrating not just a sinking, but another critical step towards starving Britain into submission, a victory in the single most critical front of World War II. This destruction was no fluke. It was the result of a massive technological and strategic advantage orchestrated by Admiral Karl Dönitz, the mastermind of the U-boat fleet. Dönitz knew that Britain was an island nation entirely dependent on imports, and he correctly surmised that cutting off this lifeline was the simplest path to victory. His U-boats were the perfect weapons, stealthy, deadly, and, crucially, untrackable by the Allies' existing technology. Winston Churchill himself admitted that the only thing that truly frightened him during the war was this U-boat menace, and the reason for this terror lay in a fatal technological deficiency of the Allies' primary detection tool, the ASDIC. While ASDIC worked by emitting an acoustic ping and listening for the echo, it was defeated by two fundamental flaws in underwater physics and design. Firstly, natural temperature and salinity shifts in the ocean created thermal layers, which could deflect the sound waves, creating vast shadow zones where U-boats could hide in plain sight. Secondly, and most fatally, ASDIC had a massive blind spot, a cone directly beneath the attacking escort ship. Once the U-boat captain expertly dove beneath the escort's stern and silenced his engines, the escort was effectively deaf, and the U-boat was free to launch its torpedoes and escape. This fatal flaw was the very foundation of Dönitz's infamous Wolfpack tactics, allowing them to gather at night, overwhelm the few lightly armed escorts, and unleash coordinated slaughter. The statistics from 1942 were catastrophic. $6.2 million tons of vital material and thousands of lives were lost, forcing the Allies into a race between German ship sinkings and Allied ship building, a race the Allies were losing. The worst stretch was the Mid-Atlantic Gap, a $500-mile stretch beyond the reach of Allied air cover, where the under-equipped corvettes of the vastly overstretched Royal Canadian Navy were the only protection. Dönitz was confident he had the war won, asserting that the enemy had been given their chance to defeat the U-boat offensive and had failed to take it. The survival of the entire Allied cause hinged on a technological counterpunch, a complete, urgent overhaul of the failing anti-submarine warfare ASW apparatus, focusing entirely on a solution to the problem of detection. The British, masters of electronics, had developed the Hedgehog, a head-throwing weapon to hit the U-boat in the blind spot. But a powerful weapon was useless without an accurate targeting system. The problem was immense, requiring a fundamental rethinking of the physics of sound in water. It was at this desperate juncture that the focus shifted to Canada, the logistical bridge between North America's immense industrial capacity and Britain's dire military need. In late 1941, the Canadian government created the National Research Council of Canada, NRC, to spearhead military R&D. But the highly sensitive, top-secret acoustic research needed to be centralized and protected. It required a pool of brilliant scientific minds who could focus solely on the esoteric challenge of underwater physics. A secret agreement was struck with the British Admiralty, and the location chosen had to be close to the open sea for realistic testing, yet discreet enough to avoid German intelligence, while possessing the infrastructure to support advanced physics and engineering. The final site chosen for this ultimate scientific struggle against the U-boat menace was the most improbable location for a major military innovation, McGill University in Montreal. This decision led to the establishment of the Montreal ASDIC School at the Royal Canadian Navy Shore Establishment, HMC Nonsuch. The mission was clear: turn the flawed, archaic ASDIC unit into a reliable, deadly precise hunter by solving the problems of the blind spot, the thermal layer, and, critically, developing training to ensure thousands of inexperienced Canadian sailors could operate the complex new acoustic devices under the extreme duress of a convoy battle. The stakes were astronomical. If McGill's scientists could not find a way to make their escorts see the U-boats, the convoys would stop sailing. Britain would fall, and the war would be lost before a single American soldier could effectively contribute. This secret, high-stakes race against time, fought not on the battlefield, but in the sterile, classified labs of a Canadian university, was about to determine the course of history. November 1941. Montreal, Quebec, Canada. Classified labs. McGill University campus. The stakes could not have been higher, and the environment could not have been more incongruous. The weight of the war, measured in sinking tonnage, rested heavily on the minds of a small, eccentric group of scientists now assembled in the unlikely sanctuary of McGill University's downtown Montreal campus. These were physicists, mathematicians, and acoustical engineers, many of whom had been teaching theoretical science just months before, now tasked with solving the deadliest technological problem of the war. Their classroom was now the classified lab, and their sole objective was to weaponize sound, turning the deep, cold black of the Atlantic into a transparent stage for the Allied escorts. The project, cloaked in extreme secrecy under the umbrella of the National Research Council of Canada, NRC, focused relentlessly on solving the two great flaws of the existing ASDIC system: the thermal layer problem and the devastating blind spot. The air inside the labs was thick with cigarette smoke and the scent of fresh solder as these brilliant, yet exhausted minds tackled a problem defined by the unpredictable physics of the ocean. The thermal layer was a physical nightmare that granted the German U-boats immunity. Sound waves, traveling through water, would refract wildly when hitting a sharp boundary between warm surface water and colder depths, effectively creating vast shadow zones that the U-boats expertly exploited, diving just below them to become invisible to the ASDIC's ping. The solution demanded a deep, immediate understanding of oceanography, a science largely ignored until the war. The McGill team, leveraging the university's unique position, established a specialized branch to research hydroacoustics. Led by researchers who understood the subtle shifts in Canadian waters, their breakthrough was deceptively simple in principle, yet revolutionary in application. Instead of simply bouncing a fixed signal off the submerged U-boat, they needed a device that could look through the thermal layer. Their experiments involved meticulously varying the frequency and power of the acoustic pulse, tuning it specifically to the average thermal conditions of the North Atlantic. They developed a new type of SDIC transducer that could emit a much higher frequency, tightly focused ping, allowing the signal to penetrate the layers rather than being merely deflected by them. The technical name for this innovation was complex, but its outcome was clear. The U-boat's favorite hiding place, the protective thermal blanket, was shrinking rapidly. The scientists were, in effect, inventing a new way to see underwater. Yet, the blind spot remained the most immediate and deadly tactical challenge, responsible for the loss of countless escort ships. Once the escort ship was directly overhead, the U-boat vanished from the ASDIC screen, giving the German commander several precious, fatal minutes to line up his torpedoes and slip away undetected. The existing countermeasure, the Hedgehog mortar, was a decent weapon, but its targeting was too reliant on the flawed, old ASDIC readings, often missing its mark. The McGill scientists realized they needed a complete change in perspective, moving away from intermittent sound pulses to continuous tracking and precise range finding right up to the point of attack. This led directly to the development of the Type 144Q ASDIC set, often simply called the Canadian set. This was not merely an upgrade. It was a fundamental redesign. The new 144Q included a system known as scanning sonar. It wasn't just a fixed beam, but an electronically controlled array that could continuously scan the area immediately below the escort as the ship moved, effectively eliminating the blind spot by locking onto the submerged U-boat right until the moment of the launch. This meant that the U-boat commander could no longer evade the escort simply by diving deep and waiting. The hunter was now also the spotter. Early 1943, Halifax Harbour and the NRC Shore Establishment, Nova Scotia. The McGill team also focused intensively on the human factor. They understood that even the best technology was useless if the operators were not perfectly trained to interpret the confusing data under the stress of a depth charge attack. At the Montreal ASDIC School, HMC Nonsuch, which fed directly into the fleet bases in Halifax, they pioneered revolutionary training methods. Sailors, often young and inexperienced, were thrown into sophisticated simulators, acoustic mock-ups that recreated the terrifying, confusing sounds of a full battle, including the U-boat's subtle metallic noises and the distracting echoes of wrecks and whale songs. The instructors, many of them the very scientists who had designed the equipment, taught the sailors not just how to interpret the screen, but how to understand the psychology of the German captain and the subtle changes in the ASDIC echo that indicated a U-boat was diving to exploit a thermal layer. This rigorous, high-fidelity training transformed the average Canadian corvette operator from a passive listener into an aggressive, lethal hunter. The ultimate breakthrough was the integration of the new Type 144Q detection systems with the head-throwing Hedgehog weapon. The old method of dropping depth charges over the stern meant the escort had to steam past the U-boat, losing contact due to the blind spot, and forcing the commander to guess the U-boat's position. Now, with the continuous, precise tracking of the Type 144Q, the escort could maintain a deadly lock on the U-boat right until the last seconds, enabling an accurate launch of the Hedgehog mortars over the bow. The combination was the technological equivalent of a surgical strike replacing a wild guess. This small, secret scientific project, fueled by an unrelenting sense of urgency, had successfully overcome the physical laws that had protected the German U-boats for so long. The ASDIC, once a symbol of Allied helplessness, was now the sword of vengeance. The moment of truth, the confrontation between German tactical genius and Canadian scientific precision, was fast approaching in the icy chaos of the North Atlantic. The U-boat sailors, accustomed to their safe, silent environment, were about to discover that their invincible realm had just become a death trap. March 1943. The Mid-Atlantic Gap, 400 miles west of Ireland. The North Atlantic air was a freezing sheet of spray and mist, but below the bridge of the Royal Canadian Navy, corvette HMCS Chilliwack, a new kind of tension hung in the air. This time, it wasn't the despair of the hunted, it was the coiled readiness of the hunter. Lieutenant Hugh Murray, the vessel's commander, watched the chaotic waves, but his focus was entirely on the silent, glowing screen in the Aztec hut below. Murray was part of the first wave of Canadian commanders to be trained at the new Montreal Aztec School, and his small, unglamorous ship was now equipped with the revolutionary Type 144Q detection set, fresh from the labs of McGill. Meanwhile, 100 feet beneath the churning surface, Captain Lieutenant Heinrich Schroeter of U-338, a seasoned Wolfpack veteran, was completely confident. He was stalking convoy SC-122 and had $15 other U-boats gathering around him. Schroeter believed he was operating in the safety of a deep thermal layer, the ocean's natural cloak that had always rendered the clumsy Allied surface ships blind. The battle began predictably. At dusk, the Wolfpack surfaced and launched its initial torpedo salvos, causing chaos among the convoy's perimeter. As the escort scrambled, Schroeter ordered U-338 to dive deep and silent, fully expecting the surface ships to lose contact as they passed overhead, just as they always did. This was the moment of tactical supremacy, the U-boat's untouchable minute. But things were immediately, terrifyingly different. Instead of the usual, weak, fading echo of the old Aztec, the Canadian operators on Chilliwack were receiving a strong, continuous ping. The new, higher-frequency pulse, born from the hydroacoustics research at McGill, was slicing through the thermal layer as if it didn't exist. Inside the Chilliwack's Aztec hut, the operator, a former physics student himself, kept his tone calm. Target steady, bearing 350, range 1,000 yards, contact maintained. The true, horrifying revelation for the Germans came in the next few minutes. Following the old doctrine, Schroeter held his breath, waiting for the blind spot to swallow the approaching escort's sound. He listened intently for the surface ship to pass over, signaling his chance to reload and escape, but the dreaded ping never faded. It grew louder, sharper, more insistent, tracking the U-boat with an unnerving, continuous certainty. The Type 144Q's scanning sonar was working flawlessly, eliminating the blind spot entirely. In the confined space of U-338, the mood swung from cautious confidence to pure, paralyzing disbelief. Schroeter realized, in a flash of cold dread, that his invincible submarine was, for the first time, completely exposed. His safe tactics were now a liability. Murray on the Chilliwack didn't hesitate. With the target locked and tracked continuously, he was able to maintain his attack vector. He didn't drop the depth charges over the stern and hope. He slowed his ship slightly, stabilized the bow, and then waited for the Aztec operator's final, deadly accurate calculation. Range 200 yards, steady bearing, fire the Hedgehog. The command was sharp and precise. A moment later, 24 $1 spigot mortars launched from the Chilliwack's bow, arcing over the water in a terrifying fan pattern, their fusion pistols set to detonate only on contact. Inside U-338, Schroeter heard the distant, unmistakable sound of the mortars entering the water above him. Unlike the massive whoosh of a depth charge explosion, The hedgehog's sound was followed by silence, until boom, 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 not one, but three simultaneous, metallic, internal explosions ripped through the hull of the U-boat. The hedgehog, guided by McGill's pinpoint ASDIS, had delivered a fatal, silent blow. U-338 buckled. Its lights failed, and the pressure hull began to crumple. Schroeter and his men, the kings of the Atlantic only months before, were sinking. They couldn't understand how the escort had maintained contact, how the thermal layer had failed, and why there was no blind spot. They realized they hadn't been fighting a blind man anymore. They were fighting a machine that could see. The sinking of U-338 was not an isolated incident. Over the next 6 weeks, a string of devastating losses shook the confidence of the Kriegsmarine. In the battles for convoys SC-122 and HX-229, U-boats sank $21 ships, but they lost $8 of their own, an unsustainable exchange rate. This was the terrifying shift, the Black May for the German submarine force. By May 1943, Dönitz himself was forced to acknowledge the new, horrifying reality. He noted in his war diary that the enemy has achieved a considerable success in the field of radio location and detection. We are, for the moment, without the means of counterattack. He was, of course, referring to the Allied mastery of radar and code breaking. But the immediate, tactile terror for the U-boat sailors came from the new ASDIC sets that were killing them. The untrackable U-boat had become a sitting duck. The technology secretly developed in the quiet labs of a Canadian university had rendered their greatest weapon obsolete. The sailors of the remaining wolf packs began to refer to the surface as the Iron Front, a boundary they now dreaded crossing. The tide of the Battle of the Atlantic had officially turned. Late 1943, Naval Headquarters, Northwood, England, and Montreal, Quebec, Canada. The atmosphere inside the Allied war rooms had changed entirely. The charts, once dominated by the endless red tide of sunken Allied ships, now showed an alarming spike in black marks, destroyed U-boats. The strategic impact of the new ASDIC technology developed at McGill, the Type 144Q, was immediate and undeniable. The losses inflicted on the wolf packs during the battles of March and May 1943 had been the strategic turning point. Admiral Dönitz, witnessing his veteran U-boat commanders, the very best of the Kriegsmarine, failing to return, was forced to order a temporary, strategic withdrawal from the North Atlantic. He could not, and would not, send his men to fight a detection system that had rendered his submarines obsolete. The psychological effect on the German sailors was as crippling as the physical damage. They had been the apex predators of the sea, operating in a world where stealth equaled safety. Now, that world was gone. Stories circulated in the U-boat pens of escort ships that could see you regardless of depth or thermal layer. Ships that dropped deadly accurate salvos directly onto the hull where the old depth charges couldn't reach. The confidence, the ruthless swagger of the early war, evaporated, replaced by the grim realization that their technology, their tactics, and their survival depended on an acoustic principle that had been decisively solved in a university laboratory they'd never even heard of. For many crews, their invincible U-boats had become nothing more than steel coffins. The convoy system, the lifeline of the war, was saved. The victory in the Battle of the Atlantic was not a single, spectacular event. It was the cumulative result of numerous, often secret, technological and strategic advancements. But the Canadian contribution, the scientists at McGill and the rigorous, practical training developed at HMC Nonsuch was crucial. They had closed the mid-Atlantic gap not just with long-range aircraft, but with surgical precision detection. The work at McGill was about far more than just the 144Q. The research laid the fundamental groundwork for modern underwater acoustics. The techniques they pioneered in analyzing sound refraction, transducer design, and high-fidelity sonar simulation became the global standard for naval warfare and, eventually, for civilian oceanographic research. The seemingly mundane pursuit of physics in a Montreal lab had fundamentally changed the balance of power on the world's oceans. The Canadian commitment to this war-winning science often goes unrecognized, while the spotlight often shines on the weapons and the battles. The real story is in the logistics and the brain power that sustained the fight. Canada was the only nation to successfully manage the entire life cycle of anti-submarine warfare. They developed the theory, McGill, built the equipment, Canadian industry, trained the crews, HMC Nonsuch, and fielded the vast majority of the escort ships in the critical years, the corvettes and frigates of the Royal Canadian Navy, armed with the precise, deadly eyes of the McGill Aztec, ensured the safe passage of millions of tons of cargo, allowing Britain to fight and, crucially, allowing the American war machine to fully deploy to Europe. Without the safe sea lanes secured by these scientific and naval efforts, the D-Day landings would have been logistically impossible. Today, the physical labs at McGill have long since been repurposed, and the names of the physicists who cracked the sonic code of the Atlantic are largely forgotten by the public. Yet, their legacy endures in every submarine detection system used by modern navies and in every piece of sonar technology used to map the ocean floor. The story is a powerful reminder that wars are won not just by soldiers and generals, but by the unseen contributions of scientists and engineers working quietly in the background, solving the seemingly unsolvable problems. They turned an abstract vulnerability, the physics of sound in water, into a definitive Allied advantage. The German sailors who couldn't believe their U-boats were obsolete were right to be terrified. They were facing an enemy armed with the superior knowledge forged in a classified Canadian university lab. It was a victory for science, a victory for the convoys, and the turning point that allowed the Allies to finally win the Battle of the Atlantic, securing the foundation for victory in the West. The incredible story of how a university in Montreal quietly defeated the deadliest weapon of the Kriegsmarine is a testament to the power of targeted, scientific brilliance. It proves that the most critical battlefields are often hidden from plain sight, and that concludes our deep dive into one of World War II's greatest untold technological secrets. The victory was about science, not just firepower. If you were surprised to learn that a Canadian university played such a pivotal, secret role in saving the Allies, hit the like button and share this video with a friend who loves history. And here's the challenge. What other secret wartime technology, like the German U-boat or the Allied sonar, do you think had the biggest unseen impact on the war? Let me know in the comments below. Don't forget to subscribe for more deep dive analyses into the untold stories of history and technology that changed the world.